Hi guys, welcome back. It's Nick here, back again with the Transport Game in Unity 5 tutorial series. Where we left off, I'll just play the game here. We just finished creating procedural terrain for our game, and all of our terrain tiles line up correctly. And we have this really mountainous terrain, and I'm really pleased with the result we've got so far. And today what I thought we'd do is move on to, first of all, texturing, and also fixing a few things that, well, making a few modifications to the existing system. And so the first thing I want to do is go into a terrain manager and change the chunk size X and Y. I'm going to double them to 5112 by 5112. For some reason when you do this you need to change this 4 to an 8. I really don't understand how the terrain size sort of is calculated from this vector 3. If anyone can help me with that, I'd be really interesting to see. But yeah, you have to change it to an 8 to get it to go to the correct size. And this is just going to make our terrain segments a bit larger, so the view distance is a bit further, but without adding loads of extra chunks. And I'm just going to grab the main camera here and I'm going to drag it up to about well, I think 350 on the y-axis to start with, just so the camera is probably above the terrain. Give that a play. Okay, so now you can see our terrain is much higher up. Let me just move around a bit. And it fills up the draw distance, which is exactly what I want. But when we increase the terrain size, the size of the hills and that has decreased. And the reason for that is, as we increase the terrain size, you're effectively spreading out the height map. So the severity of the hills and such is almost half of what it was. The reason for this gap is because we're loading old data which isn't fully implemented yet. So to make this look as good as it was, but in the larger size, I'm going to just increase the severity of the randomness. So I'm going to go down to the get random height function. I'm going to change this to 0.2. It's not going to make a big difference, but it will make our terrain a bit more random. So there you go, now our terrain is a lot more rocky. You see here it has gone down into the ground, which is okay because we'll add some water effects later to cover that up. But yeah, so our procedural terrain is looking quite good. But it would look a lot better if we actually had some texturing on it. So the feature we're going to work on next is actually procedural texturing. Okay, so a terrain is textured using what's called a splat prototype. If I go on to terrain in Unity and we click on the textures tab, go to edit texture and add texture, there's a lot of information here. So we've got two texture 2Ds slots and size and offset parameters, along with when you actually put a texture in here, like let's just use this one, you get a metallic parameter as well. So there's more to just putting an image on here. However, if I show you, my original plan was to create something like this when we do public splat prototype, it's an array, and I'll call it terrain textures. And then you go into the inspector on terrain manager and you fill in all the textures. Except that doesn't work. And the reason for that is the splat prototype is set up in such a way that it doesn't show up in the inspector. I won't go into the details here. I think it's something to do with serialization. Again, if someone is an expert in the comments, I would welcome a more detailed response. But I don't want to tell you guys anything I'm not completely sure on. So instead of doing this, we're going to actually do it a different way. So I'm going to remove the public from this variable, and up here I'm going to create a new struct, so public struct. I'm going to call it terrain texture blueprint. And we need to add a tag to this, so this shows up in the inspector. It's called system.serializable. This means it will just show up in the inspector. And I'm going to mirror the parameters that are in the normal splat prototype in this structure. So I'm going to do public texture 2D. Texture 2D, there we go. Albedo, I don't know how to pronounce that. And normal. Yeah, ever since Unity has moved on to these natural rendering options, they've had albedo textures. I just don't know how you say that. We need a public int metallic and two public vector 2s, one called size and one called offset. And instead of having splat prototypes there, we're going to have terrain, texture blueprint, array of those called terrain texture blueprints. And the idea of this is the texture at the 0 point is going to be the one highest up on the terrain, and the texture at the lowest point in the array is going to be the one the lowest in the terrain. And the terrain textures will be mapped in a sort of almost vertical way, with a few exceptions. So the final thing we need to do is convert these terrain texture blueprints into these splat prototypes. So in the start method, I'm going to add a new for loop. Before int I equals 0, I is less than terrain texture blueprints dot length I plus plus. I don't seem to be able to type today. Just tap that back, and we'll say that terrain textures at I dot texture equals terrain texture blueprints at I dot albedo, and we need to do that for the rest of the properties. So we have normal, metallic, size and offset. So this is called normal map. I think metallic is the same. Yep. And then size, tile size, and tile offset. And these are equal to normal, metallic, size, and offset. There you go, the red lines are gone. The final thing we have to do is initialize the splat prototype array, so we just have to say terrain textures equals new splat prototype. It has to be the same size as terrain texture blueprints, so we'll just put the length of that in there, so the array is populated. And now we can apply these textures directly to the terrain. So what we can do is we can say chunk graphics at I, in this loop, dot terrain data, and then I believe it is splat prototypes. Yes, we just assign that variable to our terrain textures. Later on we'll have to add some more details so the terrain knows where to place each texture, but for now this should work. So we should have a new variable here when our script is compiled. We don't. Why is that? I didn't make this variable public. So there you go. If I make that public, it will show up in the inspector. For now I'm just going to add one texture. My favourite one is this terrain assets, this mud rocky, so I'll just put that in, and the default size is 15 by 15. You can't set defaults in a struct as far as I'm aware. Again, if someone knows better, do let me know. So now if we play, we get a null reference exception. Let's have a quick look at that. I think we might have to do terrain textures at I equals new splat prototype to initialize each one in the array. Otherwise that one is null. Okay, let's give this another go. Okay, so now we have our terrain with all this mud rocky texture, which is exactly what we want. And if you go onto the actual terrain here, you can see the texture is applied. But obviously we want more than that, and Unity comes with some quite good default textures, so I think we're basically going to use those. Okay, in this scene you can actually see the problem I was trying to describe earlier. Where this says create a sort of flat area, it's reached the minimum the terrain can go. At the edge here, it's because the edge values is 0, the new terrain has assumed that those values aren't set and will reset them with its own values. So we need some way of making sure that the terrain values just aren't 0, or we add a wildcard value. So I'm going to go for the wildcard route. I'm going to do public static float and call it terrain, or I'll do terrain in caps, terrain height wildcard. I'm going to make that equal to -1. And we just need to modify a few things in here. In set terrain height map, heights must be initialized to that wildcard, so we need to say I'm not sure if a for each works with a two-dimensional array. We can float f in heights, f equals terrain height wildcard. I'm not sure if that will work because it's two-dimensional. Oh, it wouldn't work anyway because the way for each works. Okay, we'll just have to do a for loop. So int x equals 0, x is less than heights dot get length 1, y plus plus, sorry, x plus plus. I'm used to using I as my variable. And we'll nest another loop in here for y. We've just this changed to dimension 0 for the length. And here we'll just say heights at y comma x is equal to terrain height wildcard. And now later on, instead of comparing it to 0 in our diamond square algorithm, we will compare it to the terrain height wildcard. In fact, I might try and do a find and replace here. Quick replace. So if I search for 0, replace it with this. Go to find next. You can replace it in all the places that. Actually, I think I made a mistake then. This should actually be 0. Okay, so we're now changing this one. And we can just go through and change all the ones that need changing. We need to skip these ones, the greater than zeros, and just change everything else where a 0 comes up to this terrain height wildcard. Okay, so I think that's all of them replaced. Kind of hard to tell. We'll give this a go and see if this actually fixes the problem, which it hasn't. It seems to have just stopped straight away. Let's double check that wildcard is correct. Okay, so I think I've added all the terrain height wildcards we actually need, so I'm going to give this a go. And hopefully we'll get a can actually test to see if it made any difference. At least we've still got our terrain generating correctly, which is one good thing. Okay, yes, so the pool here, the terrain is clearly 0 on the border and it is transferred correctly. There's no sort of weird edging going on. Okay, so I know this has been a bit of a weird episode. We've done a couple of different things. Next time we're going to continue working on our texturing component and allow the system to choose certain textures based on the steepness of the terrain and also its height. So until next time, thank you very much for watching, and my name's been Pearson.